Okay, we're going to cover Module 3 Homework 1 and also Module 3 Homework 2. So we'll start by looking at the square root of 9. The square root of 9, I hope you all know, is 3. Now, why is it 3? Because the square root of 9 is asking what number can you multiply by itself so that you end up with 9? And that number is 3. So that's why the square root of 9 is 3. Now, a square root has an invisible 2 in the corner. In other words, there's really a 2 here, but you don't have to show it, and we ordinarily don't show it when you have a square root. Okay, each of the parts of this have a name. The index is the 2. The radicand is the thing inside of the radical, so in this case it's 9, and the radical symbol is that. In other words, the square root of 9 has a radical symbol with a radicand of 9 and an index of 2. Okay, this is the cube root, or the third root, of -8. Now remember, the square root was asking what number times itself will give you the thing you wanted. There's 1, 2 things you're multiplying by because a square root has an invisible 2 there. Well, the fact that a third root has a 3 there means the question's asking what number would you multiply by itself 1, 2, 3 times so that you end up with the radicand, in other words, the number on the inside. And if you give it some thought, you'll realize that that's -2. So the third root of -8, and a third root is also called a cube root. The third root of -8 is -2 because -2 times -2 times -2, 1, 2, 3 of them multiplied together give you -8. Okay, what is the square root of -25? Well, again, a square root really has a 2 there, which means we're asking what number times itself is -25. Well, think about it. Could that number be positive? No, because a positive times a positive will not give you a negative, so it's not positive. Could that number be negative? No, because a negative times a negative will also give you a positive, it won't give you a negative. There's no way in the world you can take a square root of a negative. And so there is no, well, you know what? Let's just say this is undefined. We'll have a lot more to say about that later, but not at the moment. Okay, there's a rule about fractional exponents. It turns out that a fractional exponent is secretly a radical, and there's 2 different ways to write it. In other words, if you have something raised to a fractional power, I call the numerator a and the denominator b, well, that is really a radical with an index of b. In other words, the denominator becomes the index, and the numerator can go in one of 2 places, either on the inside as a power, or you still have the denominator being the index, and then the numerator can go on the outside as a power. So when you have a fractional exponent, that really means you have a radical, which you can write either one of those 2 ways. So we're going to use that rule to rewrite this. Remember, a square root secretly has a 2 there. And anything you can always think of as having a 1. So the square root of x is the same as saying the second root of x to the 1. Now we're going to rewrite that using fractional exponents by using this rule right here. Whatever the index is becomes a denominator, so this will become x to the fractional power that has a 2 on the bottom. And whatever the power is on the inside, that becomes the numerator, and so that becomes a 1. So the square root of x is the same as x to the 1/2. That's a useful thing to know. That comes up now and then. So it's good to, in a sense, memorize that. Okay, now we're going to simplify the third root of x to the 15. The way I'm going to simplify that is I'm first going to turn that into something to a fractional power. Remember, the denominator is going to come from the index, and the numerator is going to come from the power here. So the third root of x to the 15th is the same as saying x to the 15 thirds, but I'm not done yet. 15 thirds reduces to 5, and so the answer is x to the 5th. The third root of x to the 15 is the same as x to the 5th. Notice, if you take the number on the inside and divide it by the index, that tells you the power you're going to end up with. And that would always work, as long as you can evenly divide them. If you can't, then we'll look at that soon as how you handle that. Okay, we're now going to use that same rule to simplify this. Before I do that, I just need to give you a new rule. If you have a radical, and inside the radical, you have a product of things, well, it turns out you can split that product into parts. And we'll use that rule a lot. So let's take this thing here. It's negative the square root of 144 times x to the 20th. I can split that into negative square root of 144 times square root of x to the 20th. Now the square root of 144 you can do in your calculator. You'll see that's exactly 12. And the square root of x to the 20th, well, I can use the thing we did a moment ago. Remember, there's secretly a 2 there when you have a square root. In other words, when nothing is showing there for the index, it means you really have a 2. And if you remember what we did last time, the radical disappeared, and we divided the power by the index, and 20 divided by 2 gives you 10. And so the answer to this is negative 12x to the 10th. Okay, Module 3, Homework 2. We're going to simplify 9x to the 10th, all raised to the negative 1/2 power. Well, if we use our exponent rules, and we use, where is it here? I guess I'm going to use this rule right here. We know that when you raise something to a negative power, and that's what we've got, a negative power, that's the same as having 1 over the very same thing to a positive power. That's what this rule is telling us. Then, if you remember what we saw a moment ago, we notice that the square root of something means the same as having that to the 1/2 power. So that means when you see something to the 1/2 power, one moment here, when you see something to the 1/2 power, that means it's really under a square root. So I can rewrite this as the square root of 9x to the 10th. I'm still not done. Remember the rule I told you a moment ago. when you have a square root of a product, you can split that into 2 square roots. Be careful. That does not work for addition, and that rule does not work for subtraction. It only works for multiplication. So be careful. So this becomes 1 over the square root of 9 times the square root of x to the 10th. Well, the square root of 9, we all know, is 3. And the square root of x to the 10th, well, the square root of x to the 10th, sorry, not square root of 10, the square root of x to the 10th, remember there's really a 2 there. And remember the way that works is you're basically going to get rid of the radical, and you'll divide the 10 by the 2, and that gives you 5. So the square root of x to the 10th is x to the 5th, and this is our final answer. In other words, this expression is equal to 1 over 3x to the 5th. Okay. Now we're going to rewrite this expression. We're going to rewrite it in 2 ways. We're going to rewrite it so it has an exponent. We're going to rewrite it as a radical. We'll start with the exponent. This expression is actually multiple ways you could go to the next step, but I prefer to use the product rule on this. The product rule works as long as the bases match, which they do, and then you do something with the exponent. What we're doing with the exponent is the product rule says to add them. So this is equal to x to the 3/7 plus 3/7, and that would be x to the 6/7. So that's equal to x to the 6/7 power. Now we're going to change that to a radical. Let me scroll down for a second here. Remember, if you have something raised to a fractional power, you can turn it into a radical by taking the denominator and making that the index, and taking the numerator and making that a power. So I'm going to rewrite this as a radical. The denominator becomes the index, and the numerator becomes the power. So this is equal to this, and it's also equal to that. They're all the same thing. Okay, I'm going to simplify this. Now, this is something that students often get wrong. So take a moment, pause the video, try this, see what you get, and then start the video up again and see if you get the same thing that I got. Okay, I'm hoping you paused it. Now, this is a little bit tricky. If it said -49 in parentheses to the 1/2, well, that would mean, and remember, a 1/2 power is the same as having a square root. That would mean the square root of -49. But that's not what this said. There was no parentheses there. When there's no parentheses and you have a negative number raised to a power, the power only applies to the number. It does not apply to the negative. If you wanted to apply to the negative, you need to put parentheses to indicate that. So this is really equal to the negative of whatever you get for 49 to the 1/2. And anything to the 1/2 means the square root of that. So that's negative of the square root of 49. And that would be the negative of, since the square root of 49 is 7, -7. And that is the answer. Okay, we're going to do this one here. Again, I'm going to remind you of the rule. If you have any kind of radical, no matter what the index is, I'll just call the index C, and you have multiplication inside of that, you can split that into two separate radicals. That's what we've got here. So this I can split into the fourth root of 81 times the fourth root of x squared. Well, the fourth root of 81 is asking me, what number can I multiply by itself 4 times to get 81? And if you try it, you will see that is 3. So the fourth root of 81, that's 3. Okay, let's look at this. Remember our fractional exponent rule. If you have something that looks like that, and that's what we've got, you can rewrite it without the radical by making a fractional exponent. So this is equal to x, one moment here, x to a power. And remember, the index becomes the denominator. So the index of 4 will be my denominator, and that makes the 2 the numerator. But this I can rewrite by reducing the fraction, and so that is 3 times x to the 1/2. Now, if I didn't indicate how to write the answer, this would be a fine way to write it. But if I said the final answer needs to be a radical, we need to take this one more step. Because remember, again, anything to the 1/2 power means you have the square root of that. So that part is equal to the square root of x. So we could write that either as 3 times x to the 1/2, or we could write that as 3 times the square root of x. Okay, this one's a little bit weird. We're going to multiply these together, and then we are going to write the final answer as a radical. I highly recommend that you pause the video, try doing this on your own, do the best you can with it, turn the video back, restart the video, and then I will show you how to do it, and we'll see if you got it right. It's a hard one, but still give it a shot. Okay, I hope you tried it. Here's how it works. The third root of x, that's the same as saying the third root of x to the 1, and that's equal to x to the 1/3. So we're going to replace that with x to the 1/3. So this expression becomes x to the 1/3 for the first part times this part by the same reasoning as x to the 4/5. Now we're going to use one of our exponent rules. We're going to use the product rule again. The product rule says this is equal to x to the 1/3 plus 4/5 power. Well, 1/3 plus 4/5. To add those fractions, I need to get common denominators. So I'll multiply the top and the bottom of this by 5, the top and the bottom of this one by 3. That will give me 5/15 plus 12/15, and that is 17/15. So that means this is equal to, one moment, where did I go? I think I need to copy this down. So the x to the 1/3 plus 4/5 power, since we just figured out those two fractions add up to 17/15, is x to 17/15. And now we can use this rule to rewrite that as a radical. Remember, the denominator becomes the index and the numerator becomes the power. And that is our final answer. The 15th root of x to the 17th power. This is equal to the 15th root of x to the 17th power. Oh, and that's the end. So that's the end of module, what is it? Module 3, homework 2, and we also did module 3, homework 1.